After understanding how black holes are born and what they are made of, we now drift toward the unknown, where secrets unfold and puzzles linger in the silent dark. The unsolved mysteries of black holes. Let us step quietly into the hidden music of the universe. More than a century ago, in 1916, Albert Einstein predicted that massive cosmic events could send ripples through the very fabric of space and time. He called them gravitational waves. For decades, this idea remained a theory, a whisper, without proof. Until the year 2015, when the Laser Interferometer Gravitational Wave Observatory, known as LIGO, captured the first faint tremor from deep space. Two black holes had collided about 1.3 billion light-years away. In a moment shorter than the blink of an eye, they merged, and the universe responded. Tremendous energy was released, equal to converting 3 times the mass of our sun directly into pure energy. These waves stretched and squeezed space itself as they passed through Earth, so delicate that only the most precise instruments could notice their rhythm. Imagine the fabric of reality vibrating gently, almost imperceptibly, yet carrying the story of a cataclysm across the ages. That first signal lasted only 0.2 of a second, but in that brief instant, humanity confirmed that Einstein was right. Gravitational waves were no longer just an elegant thought on paper. They became a doorway to understanding hidden collisions in the silent dark. Each wave is invisible, but each carries a tale from regions we cannot see. They are the echoes of giants, colliding in silence, and their resonance reached us after traveling across billions of years. What secrets lie within these unseen ripples of space-time? And what else might they be trying to tell us? Think of gravitational waves as the cosmic symphony that never ends. Each wave is like a note in a song that began long before life existed on Earth. These ripples travel across billions of years, carrying with them the memory of their violent birth. The LIGO detectors in the United States, with their long arms stretching across the landscape, are tuned to catch these almost impossible signals. Alongside them, the Virgo Observatory in Italy listens as well, together forming a global orchestra of instruments waiting for the faintest vibration. When a wave passes through, it slightly alters the length of the detector's arms, less than the width of a proton, yet enough to be measured. From these shifts, scientists can learn about the black holes that created them, their mass, their spin, and even how far away they are. Since that first discovery, LIGO and Virgo have recorded more than 90 collisions of black holes. Each one adds a new page to our cosmic storybook. Imagine for a moment that you could hear these signals as sound. You would be listening to the most ancient and powerful music ever performed, the collision of invisible giants, creating tones that resonate across eternity. The thought itself feels like a lullaby of the stars, ancient and patient. Picture yourself lying still under the night sky, your mind open to the faint hum of the universe. You would not just be hearing sound, you would be touching the heartbeat of reality itself. Now imagine listening to the oldest song ever sung, composed not by humans but by the universe itself, whispered to us by colliding black holes. The discovery of gravitational waves is not just a triumph of science. It is a doorway into the hidden motions of the cosmos. These signals reveal the dance of black holes, the way they spiral together, and the final plunge as they merge into one. From them, we can begin to map the unseen choreography of the universe, a ballet of mass and gravity that had been hidden until now. Beyond black hole collisions, gravitational waves may also uncover other mysteries, such as the meeting of a black hole and a neutron star, or the trembling of the earliest moments after the Big Bang itself. Each potential signal carries the chance of rewriting what we know about space and time. Yet the challenge is immense. The waves are often weak, faint whispers buried in the noise of Earth. Detecting them requires silence, patience, and machines of extraordinary precision. But once captured, they are priceless. Unlike light, gravitational waves are not blocked by dust or matter. They pass through everything, traveling at the speed of light, bringing with them unbroken truth from their source. They are messages written in the fabric of space-time itself. To listen is to touch the core of cosmic events, to sense the power that shapes galaxies. Imagine the universe as a great ocean, each wave a hidden tide carrying stories from unseen shores. How many more dances of black holes wait to be discovered? How many silent collisions are unfolding even now in the vastness of night? And how many secret rhythms of the cosmos are still waiting patiently to be heard in the stillness of space? Now let us turn our gaze to another mystery, a flash of light more powerful than almost anything else in the universe. Gamma rays are the most energetic form of radiation known. They are born in moments of violent creation, when black holes consume matter, or when massive stars collapse into singularities. In those instants, the universe ignites with brief but furious brightness. A gamma ray burst can last only a few seconds, yet in that short time it releases more energy than entire galaxies shine in years. Imagine a single spark outshining the Milky Way, dazzling the cosmos for a moment before vanishing. Scientists believe many of these bursts occur when a massive star dies in a supernova, its core collapsing into a black hole. And in its final breath, it releases a jet of gamma radiation that pierces the darkness. Others may be born when two stars or black holes crash together, their destruction giving rise to this radiant farewell. The truth is both beautiful and terrifying, for these bursts remind us of the immense power hidden within the universe. In their brief existence, they reveal secrets about the birth of black holes and the death of stars. They carry the fingerprints of the cosmos itself, etched into light so fierce that no human eye could ever see it unaided. One burst alone can hold the force of countless suns. And so we ask ourselves, could a single fleeting beam truly carry the might of an entire star, condensed into one final flare of brilliance? Each gamma ray burst is like a signal fire in the night sky, marking the violent birth of a new black hole. They are sudden, unpredictable, and often come from galaxies billions of light years away. To capture them, astronomers rely on space-based observatories, for gamma rays cannot penetrate Earth's atmosphere. Telescopes such as the Fermi Gamma Ray Space Telescope and the Swift Observatory wait in orbit. They're instruments designed to react instantly when a burst appears. These machines see what our eyes cannot, recording the details of events we will never witness directly. Each burst gives astronomers a glimpse into the distant past, because the light we see today left its source long before humanity existed. Gamma rays allow scientists to study not only black holes, but the evolution of the universe itself. They reveal the processes that shaped galaxies and the ways matter and energy transform under conditions we can barely imagine. NASA detects hundreds of bursts every year, and each is like a page torn from the hidden diary of the cosmos. Picture one of these bursts not as destruction, but as a flame rising from collapse, a beacon that tells us something new has been born from ruin. Imagine a black hole emerging, silent and invisible, yet heralded by a jet of light so fierce it could burn across the universe. A momentary flash becomes a message, a testimony to the power of creation through endings. A single burst, so fleeting, yet so full of meaning. A cosmic flame whispering that even destruction carries the seed of renewal. Gamma rays continue to challenge our understanding of the universe. They remind us that black holes are not just silent devourers of light, but also fountains of energy at the moment of their birth. Each burst carries information about the extreme physics near the edge of space-time, where matter is crushed and new forms of energy are released. Yet despite decades of study, the exact origins of many bursts remain uncertain. Some seem to come from supernovae, others from merging stars, and a few from events we still cannot explain. Their mystery is part of their beauty. To study them is to stand on the edge of knowledge, staring into the unknown. Gamma rays may even reveal new types of black holes, ones too small or too strange to detect otherwise. They may point us toward hidden processes that shape the early universe, or toward violent collisions happening in distant corners of space. A few bursts might even be tied to the merging of black holes themselves, an idea that brings together light and gravity in a single cosmic story. And so, as we listen and watch, we wonder, are these brief flares signs of endings or of beginnings? Are they the death cries of stars or the birth cries of black holes? Each one is both destruction and creation woven into a single flash of light. These passing bursts leave us with a lingering question. Are these glowing sparks of the universe telling us of its collapse or of its endless rebirth? Not every black hole announces its presence with light or sound. Some remain silent, hidden in the fabric of space, invisible even to the most powerful telescopes. These are the quiet ones, the black holes that do not actively consume matter, and so they emit no radiation to reveal themselves. For astronomers, they are ghosts haunting the universe. To find them, scientists must look for their influence on the stars and gas around them. A star might wobble strangely, its path pulled by a dark companion. Light from distant stars may bend and distort as it passes nearby, revealing the curve of gravity. In this way, silent black holes reveal their existence indirectly, through the traces they leave on the world around them. They may live in star clusters, in binary systems, or drift alone in the darkness, yet they are nearly impossible to detect unless something gives them away. It is as if the universe has hidden countless shadows among the stars, leaving us to wonder how many eyes are watching us unseen. Astronomers know these hidden giants exist because their gravity must be accounted for, but where exactly they are and how many they may be remains uncertain. Could the sky around us be filled with invisible traps of gravity, waiting quietly for us to find them? How many black holes without light are concealed within the darkness of our galaxy, veiled and waiting? The challenge of hunting silent black holes is enormous. Without the telltale glow of accreting matter, they blend perfectly into the void. Only the most delicate observations reveal their secrets. Space missions like Gaia measure the motions of stars with such precision that even the smallest tug from an unseen black hole may be noticed. By mapping the sky in this way, astronomers hope to build a more complete picture of where black holes are hiding. Knowing their number and distribution is essential, because they hold clues about the history of star formation and the structure of our galaxy. Some may have formed from the collapse of massive stars, others from more exotic processes. Yet despite all efforts, only a fraction of the black holes in the Milky Way have been identified. The rest remain like whispers in the night. Scientists estimate that millions of black holes should exist within our galaxy, each one a remnant of a long-vanished star. To think of them is to imagine a galaxy filled with silent shadows, each bending the path of light, each shaping the dance of stars. They are like invisible sculptures, carved into the fabric of space. And yet we pass through the night sky unaware of their silent presence. They stand there quietly, immense and watchful, guardians of secrets we have not yet uncovered. Silent black holes are reminders that the universe is vast beyond our grasp, holding more mysteries than we can count. Like ghosts, they wait in the dark, calling us to keep searching. The pursuit of silent black holes is more than curiosity. It is a quest to understand the hidden architecture of the universe. If we could map their locations, we would see the skeleton of our galaxy, a framework built not of light, but of shadow. Future telescopes in space may make this possible. Instruments more sensitive than anything we now possess could detect the bending of light with unmatched clarity. With them, we may uncover the invisible population of black holes that now eludes us. To know them is to know the story of stars. For each black hole is a tombstone of stellar death, and together they form a cosmic cemetery stretching across the Milky Way. Some may weigh as much as tens of suns, yet leave no clear trace, waiting only for the right observation to reveal their presence. To find them would reshape our knowledge of how galaxies evolve and how matter is distributed in space. Every silent black hole discovered is another piece in the puzzle of existence. As technology improves, we will see further, deeper, and more clearly into the darkness. But for now, many remain hidden, unseen shadows drifting through the galaxy. And so we are left to wonder, could we ever draw a complete map of these invisible giants? Will we ever uncover the full extent of the dark population of black holes? The question lingers, quiet as the night sky itself, inviting us to dream of the unseen world within the stars. At the center of our Milky Way, there lies a hidden giant. Astronomers call it Sagittarius, a star, a supermassive black hole 4 million times heavier than the Sun. For decades, its presence was only suspected, until patient observation revealed the truth. Stars near the core of our galaxy were seen moving at astonishing speeds, faster than any ordinary mass could explain. One of them, known as star S2, became the key to unlocking the mystery. It orbits Sagittarius, a star in a path that takes 16 years to complete. At its closest approach, it races at 3% the speed of light, millions of kilometers each hour, a motion so extreme that only the pull of a supermassive black hole could account for it. Through careful study of this stellar dance, astronomers confirmed the existence of the dark heart at the center of our galaxy. The evidence is clear. The stars whirl in obedience to an unseen master, their paths curved by gravity stronger than anything else in the Milky Way. Imagine standing on Earth yet watching a star streak around the galactic center with unimaginable speed. What would life be like if our planet lived so close to such power? Would our nights be filled with chaos and light? Or would existence itself be impossible? This question lingers like a whisper, reminding us of how fragile and distant our place is from the raging heart of the galaxy. In 2019, the Event Horizon Telescope gave us the first glimpse of this mysterious heart. By linking radio telescopes across the world into one planet-sized eye, scientists captured an image of the shadow of Sagittarius, a star. It was not a photograph in the usual sense, but a map of light bent and twisted by immense gravity. The shadow spans 50 million kilometers, 4 times the diameter of our sun. Around it swirls hot gas and dust, glowing as it falls inward. From time to time, Sagittarius, a star, flares with sudden brightness, bursts of energy that puzzle astronomers, as if the heart of the galaxy beats irregularly. To study these events is to come closer to understanding how black holes shape the worlds around them. For the Milky Way, Sagittarius, a star is not just a massive object. It is the anchor of our galaxy, holding billions of stars in its embrace. Imagine it as a cosmic heart, silent yet pulsing with hidden force, a rhythm both gentle and violent. Each flare is like a sudden heartbeat, echoing across the galaxy, reminding us that this darkness is alive in its own way. Think of our galaxy not as a scattered collection of stars, but as a living system, held together by an invisible center. And at that center lies a black hole whose mystery is both comforting and terrifying, a heart of silence, yet also of fire, quietly shaping the destiny of the Milky Way. The study of Sagittarius. A star is only beginning. Future telescopes will pierce the thick clouds of dust and gas that hide its activity, revealing details never seen before. Instruments such as the James Webb Space Telescope and the upcoming next-generation radio arrays will give us clearer vision of the swirling matter around it. With them, we may learn how supermassive black holes form and how they guide the birth and death of stars across billions of years. The connection between Sagittarius A star and the history of our galaxy is profound. It may have consumed billions of stars since the dawn of time, shaping the Milky Way into what we see today. Yet observing it remains a challenge, for we peer through dense layers of cosmic fog at a point of darkness no light can escape. Still, each new discovery draws us closer to answers. Perhaps this black hole holds secrets about the earliest galaxies, or about the unseen physics of space-time itself. It is a heart that beats not with blood, but with gravity, silent yet immeasurably strong. As we wait for clearer images and sharper measurements, we are left to wonder, what mysteries lie buried in the depths of this cosmic heart? What truths about the universe are hidden in the silence of Sagittarius, a star? And could it be that the very key to our galaxy's story rests within its shadow? Let us drift now toward the vast centers of galaxies, where almost every galaxy hides a giant at its heart, a supermassive black hole. Unlike smaller stellar black holes, these cosmic giants can weigh from millions to billions of times more than the Sun, making them the most massive single objects known in the universe. Their presence is not silent, for even though they cannot be seen directly, their influence shapes the stars around them, guiding the rhythm of birth and death across cosmic ages. In the Andromeda Galaxy, our nearest large neighbor, a black hole waits with a mass of hundreds of millions of suns. Stars swirl around it like tiny sparks, racing through the dark at unimaginable speeds, yet never escaping its pull. The Milky Way holds the same kind of giant, and so do countless other galaxies scattered through the cosmos. The fact that nearly all galaxies share this hidden core suggests that black holes are not just accidents, but architects woven into the very story of creation. Astronomers observe the way stars move near these central regions, and they see order within the chaos. Galaxies with larger black holes tend to be bigger themselves, as if a quiet balance holds both in place. Without these immense gravitational anchors, galaxies might spread apart more loosely, losing the shape we recognize in spirals and clusters. Supermassive black holes can be destroyers when they consume too much matter, but they also act as regulators, slowing or encouraging the formation of stars. Rest with this thought, that behind the shining clouds of every galaxy, there is a patient giant, unseen but enduring. One may wonder, are these black holes truly the architects shaping the fate of the galaxies? Now let us listen to the way supermassive black holes feed. For when too much matter falls toward them, the meal is far from quiet. As gas and dust spiral inward, they heat to extreme temperatures and release streams of energy that can outshine the stars of the entire galaxy. These outbursts push matter outward, slowing the birth of new stars, creating a balance between creation and destruction. The process is both violent and graceful, like a fire that burns and protects at the same time. Scientists have noticed that the mass of a supermassive black hole is linked to the size of its host galaxy. This relationship suggests that as galaxies grow, so do their central giants, locked together in an ancient dance. If the black hole grows too large, it begins to send back powerful winds, pushing away the gas that might have formed stars. In this way, the black hole becomes both ruler and guardian, deciding when stars may be born and when silence will fall instead. The force of these outflows is nearly beyond imagination. Jets of energy can race outward at speeds close to that of light, carrying enormous power across thousands of light years. These jets shape the surrounding regions, heating clouds of gas and rearranging the delicate structures within galaxies. Imagine a monarch sitting at the core of a realm, both creative and destructive, both giver of life and bringer of quiet. The black hole wears no crown, yet its influence stretches across the galaxy like unseen hands. Rest in this vision, a cosmic ruler whose choices ripple through the stars. Like a king of silence and fire, the black hole decides the fate of the galaxy it rules. The bond between galaxies and their supermassive black holes is one of the deepest mysteries in astronomy, and to understand it is to glimpse the long story of the cosmos itself. Galaxies grow, merge, and change, and their black holes grow with them, acting as companions through billions of years. To know how galaxies evolve, we must also know how their black holes breathe, how they feed, and how they rest. Yet the task is not simple. These objects are far away, buried in clouds of dust and gas, hidden behind layers of distance and time. Observing their impact requires sensitive instruments, radio telescopes, and the patient gathering of light from across the sky. Even with these tools, measuring the true influence of a black hole is difficult, for we can only see the effects on stars and gas, not the heart itself. The potential discoveries are vast. By studying supermassive black holes, we may uncover why some galaxies stop forming stars, fading into quiet collections of ancient suns. We may learn how the earliest galaxies in the young universe formed around the seeds of these giants. Each clue brings us closer to a map of cosmic history, written not in words, but in the motion of stars and the silence of black holes. It is possible that the key to understanding the life story of galaxies lies within these hidden hearts. Without them, the cosmos may have been scattered and formless, without the beauty of spirals or the glow of clusters. One may ask softly, are black holes the true keys to unlocking the history of galaxies? And do they hold the final answers to the design of the universe itself? Now let us travel back in time, to the first moments after the birth of the universe, to an age when matter was still shaping itself. Among the theories of cosmology lies the idea of primordial black holes, ancient objects that may have formed just after the Big Bang. Unlike the giants at the centers of galaxies, these black holes would have been small, perhaps the size of a mountain, or even the size of an atom, yet unimaginably dense. Some could have weighed only a few grams, while others may have carried the mass of a star, but all would have been born in the fiery chaos of the universe's beginning. If they exist, they might drift silently through space, invisible to ordinary eyes, leaving only the faintest signs of their gravity. One possibility is that these primordial black holes could explain the mysterious substance we call dark matter, which makes up most of the mass of the universe, but has never been seen directly. Instead of exotic particles, dark matter could be made of countless tiny black holes, ancient and quiet, still moving among the galaxies. Imagine something no larger than a grain of sand, yet holding the weight of mountains, scattered like shadows across the cosmic ocean. These black holes may have shaped the first galaxies, acting as seeds around which matter gathered, forming the structures we now see. The mystery deepens with each question. Could primordial black holes still exist today, drifting through the dark unnoticed? Or have they vanished over time? If such objects are real, they would be as old as the universe itself, carrying the memory of creation. And one may wonder, are these hidden relics the tiny architects of the vast universe we now call home? To search for primordial black holes is to look for shadows in the dark, for they leave few signs behind. Astronomers turn to the bending of starlight, a quiet trick of gravity called microlensing. When a black hole drifts in front of a distant star, its gravity bends the light, making the star appear brighter for a short time. By watching thousands of stars, scientists hope to catch these fleeting signals, a soft whisper that something massive but unseen has passed by. There are also theories that the smallest primordial black holes may slowly vanish, releasing their mass in gentle radiation over billions of years. This idea was first suggested by Stephen Hawking, who showed that black holes are not fully eternal, but may fade like glowing embers. If so, some of the smallest primordial black holes may already have dissolved into light, leaving only the larger ones to continue their silent journey through the cosmos. The search for these relics is not only about filling gaps in science, but also about touching the earliest story of existence. To find one would be to hold a piece of the dawn, a remnant from the first heartbeat of the universe. Imagine that somewhere, drifting unnoticed between galaxies, there moves a black hole no larger than a stone, yet carrying with it the secrets of creation. We may never see it with our eyes, but its gravity may guide the path of stars. Its silence may shape the galaxies we know. To listen for it is to listen for the quiet memory of the universe itself, hidden in the spaces between stars. The mystery of primordial black holes continues to stretch across both science and imagination. Some believe they could explain the strange distribution of matter in the universe. Others think they may reveal why galaxies form in the shapes we see today. Still more daring theories suggest that if they are real, they might even be portals to new physics, carrying us closer to truths beyond our current reach. But for now, they remain unseen, like whispers carried on the wind. The search requires patience, instruments of great sensitivity, and minds willing to follow faint clues. Sudden flash of radiation, a tiny shift of starlight, or a subtle ripple in space-time itself could all be hints that these ancient travelers still move among us. Each potential signal is checked, tested, and often found to be something else. Yet the hope remains. If one day we confirm their existence, the meaning would be profound. It would tell us that black holes were present not just in the hearts of galaxies, but in the very first seconds of creation. It would remind us that the universe began not only with light and fire, but also with silence and gravity, seeds of darkness hidden within the glow. To rest with this thought is to rest in wonder. Somewhere in the vast night, a black hole smaller than a mountain may be gliding through eternity, untouched and unseen. It carries with it a story as old as time, a story written in silence, waiting to be discovered. Perhaps when we close our eyes, we can sense them, scattered across the dark like invisible stars. Reminders that the universe still holds secrets beyond measure and mysteries yet untold. If you find peace in these mysteries of black holes and wonder in the stories of galaxies and the birth of the universe, let your curiosity rest with us. Subscribe to Cosmic Sleep Science, where every night brings new journeys through silence, gravity, and the hidden beauty of the cosmos.